Question number 9 and 10 related to this passage. And question stem reads, 2-point charges minus q and plus q by root 3 are placed in xy plane at the origin 0, 0 and at a point 2, 0. We can see from here, respectively. This results in an equipotential circle of radius r, whose potential is 0 and whose center is b, 0. All lengths are measured in meter. We need to find the unknown r and unknown b. So let's read this picture more deeper. So this is the origin and charge minus q. This is a point which is 2, 0. So this distance is going to be, this is 2, 0. So if we measure this distance, this is going to be 2 meters. And the circle which is dotted one is of radius r, and its center, this point is having coordinate b, 0, center point. And you will find this circle which is equipotential has a potential 0. So we can find any point on this circle, measure the potential because of these 2-point charges, and can claim it to be 0. Now it's going to be easier for us to take the easier points. So I'm choosing point 1 and point 2. And at point 1 and point 2, I'm going to find the potential because of all the charges available, and we will say both potentials are going to be equal because it's equipotential surface or curve, and moreover this equal value is going to be 0. So let's find the potential at point 1. So at one point the potential is going to be because of minus q as well as because of plus q by root 3 charges. From potential due to minus q will involve this distance. We need to write this distance. Now you need to find this distance. How we can find this distance? Because we know from the center, it's up to the center, it's b, and the radius is r. So if out of b we subtract the radius, then we'll find the distance needed for minus q1. So potential will become k, the charge which is minus q, divided by the distance which is b minus r. I just told you this is b and this is r. So you go b forward, then return back by r. So you will be basically moving up to the point 1. Got it? Now we need to find the location or the distance of this point 1 from the charge plus q by root 3. Now in order to find this distance, what we can do, we can find maybe this total distance, and out of this total distance we can subtract this distance. So total is b and this is 2, so the remaining is going to be b minus 2. Now we know this total distance up, this is the radius. In out of radius, if we subtract this which is b minus 2, it will work. So that will be this distance. So can we say the distance needed for plus q by root 3 charge for potential at point 1, it should be like b, this r minus b minus 2. That's written over here, which is basically k, the charge which is q by root 3, and the distance of the charge from the point 1, which is going to be r minus b minus 2. I just explained, you can rewatch. This is going to be equal to 0 because that's the total potential. Now if it is 0, so you can say this k and q will disappear, and it will be simplified as 1 by root 3. I'm writing this term first, and it's going to be like r plus 2 minus b is equal to, this will be having 1 minus b, 1 upon b minus r, because this minus will take this other side. You can check the calculation. Basically this is root 3 times, we can make them upside down. So root 3 times r plus 2 minus b is equal to b minus r. Then you can take this b minus r common, maybe bringing those numbers this side. So you'll find this is going to be 1 plus root 3, because this is r minus b. When it comes this side, so that becomes b minus r. So this 1 plus root 3 will be added together, and 2 root 3 will be surviving. So point is, we got to know that b minus r is coming as 2 root 3 divided by root 3 plus 1. You can multiply by its conjugate of this denominator. So that's going to be basically root 3 minus 1. You need to multiply upside and downside. Then you'll find in downside you'll have root 3 plus 1 into root 3 minus 1. That will turn out as 2. Then 2 and that 2 will get cancelled out. Ultimately you will have a root 3 within the bracket root 3 minus 1, or you can write it as like 3 minus root 3. That's one equation. Okay, then after what to do is make one more equation in B and R. In order to make the another equation, you need to take another simplest point, which is point number 2. So find the potential at point number 2 because of this minus q charge. So it's going to be k minus q divided by the distance. Now we need to measure this distance. We can say k up to the center it's b, this further is r, so that's a b plus r. So it's simply k minus q divided by b plus r. Again, we need to find this distance which is needed for us. So for that sake, what we can do is we can say this distance is 2, and we need to add this distance, or in fact we need to add this entire distance. So our focus is to find this distance and add with r. So we can say ki this is going to be r plus this number. Now we have just talked about earlier as well, this is going to be b, this is going to be 2, so this is going to be b minus 2. So can we say b minus 2 plus r is going to be the distance. This is going to be the total potential, it has to be 0. Again, when we are equating, so kq is getting cancelled from both sides, or you can say take them common and put it 0, or they can multiply it by 0 or whatever. So it's going to be like 1 by root 3, and this is going to be r plus b minus 2, and this is going to be 1 upon b plus r. Upside down will make like this. So again, the r plus b can be, or b plus r can be taken out. So r plus b is going to be equal to 2 root 3 divided by this number, which is root 3 minus 1. You can do these calculations, right? Again, multiply with their conjugates, then you are going to get is going to be root 3, and within the bracket root 3 plus 1, or you can say 3 plus root 3. So this is 3 minus root 3, this is 3 plus root 3. And these are the two important equations, right? One says b minus r, another says b plus r. Once you add them together, then r and r will get cancelled out, and then 3 minus root 3 and 3 plus root 3 will get added up to make it 6. Basically 2b will become equal to 6. That means b will become equal to 3. So the answer of b is going to be 3. Moreover, we can put the value of b over here. So that was 3 plus root 3. So 3 and 3 getting cancelled out. So r is going to be root 3. So r comes out to be root 3, which is 1.73. So these are basically our final answers. So r is root 3 and this is 3. This is how we need to answer. Thank you.